Thank you. I think we can move on. Our next speaker, Dr. Berit Granum from the Norwegian Institute of Public Health, is going to join us remotely. So hopefully we can get her up. And thank you so much for joining us from Norway. Really appreciate that. Can you hear us? And
I can hear you, but I'm
great.
muted.
We can see you, so we're ready to start. Thank you so much.
Okay, can you hear me? I've been muted. You have to demute me.
Yes, we can hear you. Thank you.
Can you hear me?
Yes, we can hear you.
Okay, good. I would like to thank the organizers for inviting me to this very interesting workshop. And I also no conflict of interest to declare. So firstly, background about immunotoxicity and the PFASs. In immunotoxicity, we are working with 4 outcomes when exposed to chemicals. We have hypersensitivity, that is shown like allergic diseases and asthma. And we have autoimmunity, immunosuppression, that might lead to increased risk of infections and cancers, and reduced vaccination responses. And we also have immunostimulation that may lead to inflammation or exaggerated activation of normal reactions. But today I will only focus on the immunosuppression part of the immunotoxicity. And this has already been a bit covered, but the immune system has developed extensively during the fetal period and first months of life. But also there's a continued maturation throughout childhood. So a normal maturation depends upon specific processes both at different time points and in different body compartments. And that makes the early life immune system a moving toxicological target for interaction with chemicals. And also if you get, if this system, if the maturation is disturbed by chemicals early in life, you might have lifelong consequences of that exposure. The PFASs, they consist of a fully fluorinated carbon chain and different functional groups. And the most used are PFOA and PFOS, and these 2 substances are also the most studied substances. They're widely used due to their water and oil repellent properties, and we can find them everywhere. Important exposure sources are, for instance, diets, and especially fish and other seafood, meat, egg, milk and dairy products, and drinking water. But we can also be exposed via the lungs by indoor air and house dust, and industrial pollution is also an exposure source. They have fairly long half-lives in humans, depending on the substance, but it's usually between 3 to 7 years. And they do not undergo metabolism in humans. So in European Union, these 2 substances are regulated. So PFOS and substances that might be transformed to PFOS has been prohibited since 2008. And from 2020, PFOA will also be prohibited in the European Union. I also tried to look at the US regulation, but I discovered that you have several. So I leave that up to you to find out the regulation in the US. In 2016, the National Toxicology Program in US, they made this NTP monograph on immunotoxicity associated with exposure to PFOA and PFOS. And they performed literature searches in October 2014 and 15, and the last one in May 2016. In this report, they included immunosuppression, but also hypersensitivity and autoimmunity. But I will show you the conclusions on immunosuppression. For PFOS, they found a moderate level of evidence for reduced vaccination levels in humans, and they found high level of evidence for suppressed antibody responses in animals. And there was some evidence for a reduced ability to respond to infectious diseases in animals. For PFOA, it was the same for vaccination levels in humans and antibody responses in animals as with PFOS, but they also found an increased risk of infections in humans with some weaker evidence. So the NTP's conclusion, based on both hypersensitivity and immunosuppression, was that PFOS and PFOA are presumed to be immune hazards in humans. And now I will focus on the studies they included on prenatal exposures and childhood effects. So they looked at vaccination responses and infectious diseases. And when it comes to vaccination responses, the Grand Chance study that has been mentioned earlier were used, and also our study from 2013, where both Grand Chance and we found an inverse association between prenatal exposure to PFAS and the vaccination titers of these two vaccines. When it comes to infectious diseases, they had included 3 studies. 2 of these studies show no associations between prenatal exposure to PFAS and infectious disease, whereas in our paper from 2013, there were positive associations with airways infections and gastric flu. Since the last literature search in 2016, there have been published more studies, not on vaccination responses and prenatal exposure, but on infectious diseases. When it comes to common cold and flu in the CA project, that was published as a report in 2012, and I could not find that was cited in the NTP report, but in that study, they found no associations between PFOA and common cold and flu. But there are now 4 new papers showing an association between infectious diseases and prenatal exposure to PFAS. So I believe that these new studies give even more evidence for increased risk of infections in humans after prenatal exposure to PFAS. And when we also look at the paper from Godarsi from 2017, and a paper that we have recently accepted, the Implement All Impress, we have also looked at gender differences. And there seems to be a gender difference in exposure health associations. In the study by Godarsi, they found that PFOS and PFHXS were positively associated with total infectious disease, and particularly among girls. And likewise, in our study, we found gender differences for several of the PFAS and infectious diseases. And what I show here are some of the airways infections at 3 years of age that we have included in our paper. And as you can see that many of these findings are stronger in the females than in male. So this is something I believe we should look more closely into. And the mode of action of these substances. There are some evidence that PFOS and PFOA affect immune cells, and then possibly by modulation of gene regulation via PPARs, NF-kappa B transcription, and regulation of apoptosis. But some of these mechanisms are shared between PFOS and PFOA, but there are also different mechanisms behind their effects. Most studies are based on in vitro studies or animal studies. But in 2016, we published one study in humans, and we based it on the 2013 paper where we found decreased levels of rubella titers and increased risk of common cold. And in this study, we also had core gene expression. And what we found was quite similar to the animal studies. We found an indication of role of PPAR delta. We also found indication of NF-kappa B activation, and we also saw induction of several cytokines and immunological adhesion molecules. So in this respect, the animal studies and human studies are quite similar. In the summer last year, the European Food Safety Authority, they released this risk assessment report on PFOS and PFOA. And what is a bit special about this risk assessment is that it is based on human epidemiological studies and not animal studies that we usually use in risk assessment. And for PFOS, the critical effect in adults was increase in total serum cholesterol, and in children it was actually, finally, they used antibody responses to childhood vaccinations, because often the immunotoxic effect are not used in risk assessment as the critical effect. They defined a temporary tolerable weekly intake of 13 nanograms per kilo body weight per week. And they also released this report in 2008. And the new TVI is actually 80 times lower than the old one. So it's a significantly reduced intake level. And for PFOA, the critical effect was increased serum total cholesterol, and the temporary TVI was set to 6 nanogram per kilo body weight per week. And that is 1,750 times lower than the intake level they set in 2008. So with these low TVIs, a considerable proportion of the population has higher exposures than the TVIs. There is also part 2 of this risk assessment, and they will do assessment of other PFASs. Hopefully this will be published in 2019. But in 2018, a risk assessment was also published by the US ATSDR. They based their guidance values on animal studies only. And they also risk assessed PFHXS and PFNA in addition to PFOS and PFOA. And here you can see that it's minimal risk levels per day. So it's 2, 3, 20, and 3 nanogram per kilo body weight per day for PFOS, PFOA, PFHX, and PFNA. But what I find interesting is that if you compare these minimal risk levels with EFSA's TVIs, they're very similar. For the EFSA, they defined for PFOS 13, and the ATSDR defined 40 nanogram per kilo body weight per week. And for PFOA, it was 6 versus 21. So I find it very interesting that one of the EFSA used the human studies, ATSDR used animal studies, and they ended up with similar tolerable intakes. So there's increasing evidence for immunosuppressive effect of prenatal exposure to PFASs. There's good accordance between human and animal studies seen by the EFSA and ATSDR reports, and also the mode of action research that we have. And as we heard earlier, the immune system is a sensitive target. However, there is a lack of validated test guidelines that make it more difficult to test the immunotoxic effects. Organ weights are often included in repeated dose toxicity testing, but that is a rather insensitive marker of immunotoxicity. So we need more functional immune testing, and we need more guidelines for that. Yeah, and of course, as an immunotoxicologist, I would like to have more focus on immune effects after exposure to environmental chemicals. And these are the ones that have contributed to our studies. And the picture there is taken from the Lake Mjøsa, that is the largest inland lake in Norway. And in 2003, they discovered high levels of the brominated flame retardants PBDE in fish in this lake. And they also found that the reason for these high levels of PBDEs was one textile factory that has started using these substances in the beginning of the 1990s. So when they discovered these high levels of PBDEs, they stopped using these substances in that factory. And in 2007, we saw decreased levels of PBDEs in the fish. And by 2010, the levels were actually lower than before they started using these substances in the beginning of the 90s. So I believe that this example shows that monitoring of environmental pollution and strict regulation can be a useful tool to ensure a better environment. Thank you.